Okay, welcome back. I hope you just took a short break because we're really continuing with the same topic before, but I need to keep these videos a little shorter than I had first planned. Okay, we're going to be talking again about the powers of sines and cosines, and in this case, we're going to talk about the type of integral where m is even and n is odd. Remember, m is the exponent on sine and n is the exponent on cosine. Notice we have a restriction on both m and n in this case. And here's an example. Sine squared x, cosine cubed x, even and odd. All right, now what technique do we use this time? Okay, the technique we use this time is to factor out one of the cosine factors. And once again, if this is odd, then you'll see that we're going to have the cosine times the cosine to an even power. And once again, we're going to use that same identity, okay? Look. Let's say we have this original integral, the one I used up here as an example. So sine squared stays as it is. Then I factor cosine cubed into cosine, here it is, times cosine squared. And in place of cosine squared, I use the identity 1 minus the sine squared. Okay, give me a minute to go to the next page, and you're going to see what is going to happen. Okay? Here I have now sine squared x, again I seem to have forgotten the x here, so I'll write it in real heavy so you can see it, times cosine, and then I have minus sine to the fourth x times cosine. Now these integrals are already in the form u to the n du, because if u is equal to the sine, then the derivative of the sine is the cosine. So all I have to do here now is just use the u to the n du formula, and I increase the exponent by 1 on sine squared. That gives me sine cubed x. Same thing in the denominator. Bring my minus sign down. And then I increase the exponent on sine here. So 4 becomes 5, increase to 5. And I put the same thing in the denominator. So here's my answer on that original integral where I had the sine to an even power and the cosine to an odd power. Okay, let's look at another type that fits into this category. And that type is one where both m and n are both even. So now we're going to have something that looks like sine to the fourth x, cosine to the sixth x, or something like that. Actually, one of those problems is going to be so difficult or so tedious, not necessarily difficult, tedious to work. I'm not going to work one like that with you. But here's the basic identities. These are the basic identities we're going to use. We're going to use sine squared t is 1 minus cosine 2t over 2. And cosine squared t is 1 plus cosine 2t over 2. Let me just give you an admonition that I always give my face-to-face students. In using each of these identities, I prefer not to use a letter here. I prefer to say it in words like the following. The sine squared of an angle is equal to 1 minus the cosine of twice the angle over 2. And the cosine squared of an angle is equal to 1 plus the cosine of twice the angle over 2. Because sometimes we might have sine squared 3t or sine squared 6 theta. And if that's a 6 theta, then this becomes a 12 theta because it's 2 times that. So keep that in mind as we're working some of these problems, okay? So let's work a very, very easy one. Sine squared x times cosine squared x is the actual integrand, okay? Sorry. All right, now we have, I'm just looking at the integrand now. I replace sine squared x by 1 minus cosine 2x over 2. I replace cosine squared x by 1 plus cosine 2x over 2, and then I simplify. 2 times 2 is 4, and here I have the sum and the difference of the same two terms. So you know it's the square of the first minus the square of the second. So now the integral becomes the following. Again, let me get to the next page. Okay. Notice I have factored out the 4, and then this is 1 dx. And then I have minus 1/4 cosine squared 2x. All right. Now let me show you. My admonition before is going to come into play in just a minute. Let's get rid of this first antiderivative. I don't mean get rid of by just doing away with it, but let's find its antiderivative. 1/4 dx, integral dx is 1/4 x. So we're going to keep that in mind now. Remember, that's going to have to be part of our final answer. Now let's look at the second one. Okay, and that is cosine squared 2x. All right, so now my 1/4 comes down here, and now what am I going to replace the cosine squared of 2x by? I'm going to replace it by 1 plus the cosine of twice this angle. and twice this angle is 4x, and then I need to divide it by 2. Okay, that's why I was emphasizing I'm using words like twice the angle instead of letters like t and 2t. Okay, so now let's see. 1/4 times 1/2 is 1/8, and then I have 1 plus the cosine of 4x. I just brought it down. So this 1/8 stays 1/8. Antiderivative of 1 is dx. Excuse me, no, that's wrong. The integral right here just stays the same. I didn't find an antiderivative yet. All I did was distribute the 1/8. So then I have 1/8 cosine 4x dx. Now I'm going to find some antiderivatives. 1/8 integral dx is 1/8 x. So that's going to be part of our answer. All right. Now, where am I getting this 1 over 32? Well, let's go back to this problem right here. I know that the antiderivative of the cosine of an angle is the sine of the same angle as long as I have the derivative of the angle. Well, what's the derivative of 4x? You got it, it's 4, so I put it down here. Now, if I multiply inside by 4, I need to multiply outside by 1/4, and 1/8 times 1/4 is 1 over 32, okay? So now I've got my integral right here in the form cosine u du. And so now this integral, let's just concentrate on this, is 1 over 32. And the antiderivative of the cosine of an angle, if I have the derivative of the angle, is the sine of the same angle. So this is the sine of 4x, and then finally plus c. Now I'm not done yet. Remember, I had a 1/4 x up above somewhere. So I put all of this together. This is from that first part, when, you know, the easy part. So I have 1/4 x minus all of this. And so I have 1/4 x minus 1/8 x, which is 1/8 x. And then minus plus gives me minus. So this is minus then 1 over 32 times the sine of 4x plus c. Well, that's all for now. I'll be making some more of these videos for you, so just stay tuned. Check our site, and I'll be back in a little bit.